Hello guys, Assalamu alaikum to all of you. Hope all of you will be fine today. We are going to start our lesson on properties of alkanes. So let's begin this lesson. Bismillahirrahmanirrahim. In this video, we will discuss all the properties of alkanes and alkenes. The writing formula of all the alkanes and alkenes will be given. The link will be given under this video. You can click that link and watch that video how to write the formulas of organic compounds. So all the formulas how to write will be given over there. But here if we want to discuss this structure of alkane. So this is the homologous series of alkane. If we will discuss the homologous series of alkanes, then we all know that series starts from the methane, meth 1 carbon atom, eth 2 carbon atom, prop 3, but 4, 5, 6, 7, 8 and so on. But if we will write the formula of methane here. So methane formula CH4. How to get this formula, as I already have told you in the previous lecture, the general formula of alkane is H2N plus 2. So if I want and you want to write the formula of N with pentane pant 5 with number of carbon atom 5, then in that case very easily we can put this in this general formula. This is the general formula of alkanes. So if we want to write the general formula of alkanes, then in that case we have to use this formula CnH2n plus 2, where N is the number of carbon atoms. So C5H2n plus 2, H2 multiplied by 5, and this one is N multiplied by 5 plus 2. So it will be C5 H25 10 plus 2 12. So this is the formula how we can generate rest of all the molecular formulas of alkanes. So rest of the all formulas are given in the link below this video. So next I would like to discuss the properties of alkanes. This is the homologous series of alkanes. If we will discuss the homologous series of alkanes, then first we have to go the general properties of this homologous series. If we will discuss this homologous series, then it is very necessary to know the homologous series of alkanes. So CH4 to octane, I have written the formulas here. So if we were going to discuss this homologous series, then in this homologous series all have same chemical properties. All have same chemical properties. All alkanes, because the family is the same, homologous family is same, all have the same chemical properties due to the same functional group. But here in alkanes we do not have any functional group. All alkanes are made by same chemical reactions. So the methods of preparation for all the alkanes will be same. Even we are going to talk about the methane, ethane, propane, butane, pentane, hexane and so on. We will discuss it like this. They have the same general formula. So all of this series having the same general formula, that is the CnH2n plus 2. So this is the general formula which is same for all of these homologous series. In homologous series, two consecutive alkanes differ by CH2 only. So if we want to check in this alkane, if we want to check what is the difference between these, for example, would like to check what is the difference between C5 and H12. The difference will be CH2. So in all of the compounds of these alkanes homologous series, they differ by CH2 only. So this is the difference where alkanes differ by CH2 only. They gradual change in physical properties as we go down the series. Now as we go down the series, the gradual change will be there. What gradual change will be there? First of all, if the number of carbon atoms are less at the top, then the elements, substances, methane, ethane, propane, butane, till butane, they are gases. Physical properties are changing. Then 5 to 15, they are liquid, and 16 above, they are solid. So we are going to discuss about the states, physical states First of all, how they are present at the at room temperature, that the C1 to C4 gas, C5 to 15 liquid, and C16 to onward they are solid. Now the rest of the properties which I would like to discuss here, those are in homologous series. If we would like to discuss this in homologous series. In this homologous series, as the carbon content increases, as we go down the group, number of carbon atom increases, like 1, 2, 3, 4, 5, 6, 7, 8. So number of carbon atom increases. So if number of carbon increases, then it leads to increase the density. So density of the substance increases. Viscosity. Viscosity, what does this mean? Viscosity means ease. Viscosity means ease of flow. How easily substance can flow, comes to under this viscosity. How easily substance can, ease of flow will come under this heading, that how viscosity describe ease of flow. The thickness, the light, if the carbon contents are less, then its thickness is less. First of all, gas, with the passage of time, if carbon atom increases, its thickness, its viscosity, its ease of flow increases. So because of the carbon increases, the boiling point increases, the melting point increases. So as we go down this alkane series, the density, viscosity, boiling point, melting point are increases. But what are the properties which are decreases? Flammability, because at the beginning it is gas, but with the passage of time it turns into liquid and solid. So as we go down the group, its flammability is the ability to catch fire. Flammability decreases, and volatility also decreases. Volatility means the substance which is having the boiling point just above the room temperature, or they can evaporate easily at the room temperature. They are called as volatility. So these are the physical properties of alkanes which we have discussed here. First of all, we are going to discuss now the chemical properties of alkanes. So if we will discuss the chemical properties of alkanes, so the properties the first property which we will discuss, that will be the substitution reaction. What does it mean, substitution reaction? If someone is going to substitute you or substitute any element, then we will say the substitution. So substitution is a reaction in which one or more atoms of an organic compound are replaced with one or more other atoms. Again, I am repeating, substitution reaction is a reaction in which one or more atoms of an organic compound are replaced with one or more other atoms. Like how? Let me discuss this reaction, substitution reaction. Reaction in which one or more atom is going to replace. This is an organic compound. So in this organic compound, this is a molecular formula. Chlorine reacts and methyl chloride will form and hydrochloric acid will be formed. But if I would like to discuss it in detail, what basically going on here, then you can check that this HCl will take the position of this hydrogen, and this hydrogen will take this chlorine and make a separate product, HCl. This HCl along with this Cl will move out. This Cl will take the position of this. So again I am repeating, in which one or more atoms of an organic compound, is replaced by another atom. It is going to replaced by another atom. So this is called the substitution reaction. So this reaction can take place in diffuse sunlight, ultraviolet rays or other rays, UV rays, whatever the rays in the sunlight. Diffused sunlight will be used. Direct sunlight can make an explosion. So direct sunlight is not good for this reaction, substitution reaction. Then in further, again, this, when one chlorine atom is there, along with the name will be chloromethane. And if one methane atom is attached with this, we can use the monochloromethane. First of all, we'll write the chloromethane. Is it okay? But if we want to mention the number of chlorine, monochloromethane, it shows that it has one Cl atom in this molecule. So this monochloromethane, if again will react this chlorine, so again this Cl will take the position of one H and one HCl will go along with this Cl. So if we are going to give the position this one H, this H will be, it will take the position of the upper atom and Cl will form. Chloromethane again, but the number of chlorine atoms are 2. So we will write dichloromethane. So name will be dichloromethane. Next one is the, if dichloromethane again react with chlorine, so chlorine has another hydrogen atom here to replace, so it will use this hydrogen atom to replace. So this hydrogen atom will be replaced by this chlorine atom, so it will replace that hydrogen atom, and this hydrogen atom will take this Cl and move out like this. And 1, 2, 3, there are 3 chlorine atoms with methane molecule, so we will use the word trichloromethane. So this is called as trichloromethane. This trichloromethane again react with chlorine. Here is again another H which can be displaced by the Cl. HCl will become out. There are 1, 2, 3, 4. 4 means tetra. So this will be called as tetrachloromethane. So this is the name for this tetrachloromethane. It can react with bromine as well. So not a lot of reactions involved in alkanes, because alkanes are not very much reactive. So substitution reaction is that reaction in which one or more atoms of an organic compound are replaced by one or more other atoms. So this is the replacement and substitution of the elements in the compound. So this is the substitution reaction. So another reaction which we want to discuss here is the combustion reaction. Combustion reaction. So if we will talk about the combustion, what first word comes in your mind? The burning. Okay. Combustion is the burning of a substance in the presence of oxygen. When a substance burns in the presence of oxygen, then there will be the 2 types of combustion will be produced. Now, how we will classify these 2 combustions? We will classify it like complete combustion, complete combustion, and incomplete combustion will come under this heading. Complete combustion and incomplete combustion will come under this heading. And incomplete combustion. In incomplete combustion and complete combustion, there is the difference of the presence of oxygen. So if the oxygen is sufficient enough, the supply of oxygen is very good, then we will say this is the complete combustion. So we will write that this is the complete combustion. But if the supply of oxygen is not very good, then we will say this is the incomplete combustion. So for the complete combustion, we will have sufficient supply of oxygen. If we have sufficient supply of oxygen, then we will say the complete combustion. Sufficient supply of oxygen. If in the reaction the amount of oxygen is quite good enough, then we will say this is the sufficient supply of oxygen. For sufficient supply of oxygen, complete combustion will take place. And for example, if we have to write the equation, then we can write like this: CH4. We can take any member of the homologous series, methane, ethane, propane, butane. To write this equation, the products will remain same. So methane plus oxygen, it will form carbon dioxide gas plus steam. So this is the way through which steam will produce and carbon dioxide gas will be produced. For the complete combustion, always the products will remain same. Either we are going to have to write the butane, whatever we are going to write here, the product will always remain same. That is carbon dioxide gas and steam. So these are the equations for the complete combustion. When combustion will take place, a lot of heat energy is evolved. So it leads the production of a lot of heat. So complete combustion, carbon dioxide and steam will produce. So in the incomplete combustion, the amount of oxygen is not sufficient enough. So we can say that not sufficient supply of oxygen, yeah, insufficient, not or insufficient supply of oxygen. If supply of oxygen is not too good, then in that case we can say insufficient of, then we will say that this is the incomplete combustion. So if we have to write the equation for this incomplete combustion, then we can write it like this: methane plus oxygen, it will form carbon monoxide plus steam. So if we will write carbon monoxide, so this is the product for the incomplete combustion. If we can write pentane, butane, hexane, heptane, whatever we write here, whatever we write the alkane here, the incomplete combustion always leads carbon monoxide and water molecule. So this is the combustion reaction. Now another property which we would like to discuss about the alkanes, that is not comes under the like this alkanes, like the chemical properties. It is a process which involve basically in alkanes, and it is a very specific property and very specific characteristic of alkane, because alkanes go under the cracking process. So I am going to discuss the process of cracking with you. Cracking, and the cracking is basically of alkanes. Cracking of alkanes. So this is a process which is basically in which alkanes are involved. So the process in which the big molecules of alkanes, if I am going to say you, for example, this is a very big molecule of alkane in oil, right? That molecule will be in the state of oil, can be broken up into smaller. If this a big molecule of alkane can be broken up, we will break it up into the, if we will break it up into the smaller pieces like this. Let me, like this, for example, these are the smallest pieces. This one is the big molecule, right? And we are going to convert it into the smaller one. When we will smaller one, we will break a big molecule into a small oil molecule. This process is called as cracking, right? Again, I'm repeating, the big molecules of alkanes oil can be broken up into the smaller molecules. Then we will say this is the process of cracking. Okay, why we need the cracking? What is the use for this? The long chain molecules, if it is a very long chain liquid, but I need petrol, or our industry needs petrol. So the big chain molecules will be converted into petrol for the motor vehicles, right? So this is a very good use to make the products for our own demand. So to produce fuel for motor vehicles, most of the fuel used in vehicles is produced by this process, that is cracking. So cracking is also a way of making alkenes. Oil molecules are basically alkanes. When an alkane molecule is cracked, when a big molecule, alkane molecule is cracked, then alkene molecule is also present. So for example, I will show you some of the examples they are there. If alkenes are produced, then how alkenes are beneficial for us? It will form ethanol, alcohol and plastics like polyethylene. So polyethylene is a plastic basically through which we can make from the alkene. So polyethylene is the plastic, like you have heard this name, polythene bags. So all of those are formed by the polyethylene. It is used to make hydrogen gas. This hydrogen gas is used in the Haber process for the manufacture of ammonia. So it is again used in further processes in the manufacture of ammonia. So for the production of ammonia in Haber process, hydrogen gas will be utilized. So cracking is a process in which big molecules, oil, big alkane molecules can be broken up into small oil molecules to produce the products for the more demand. So next we will discuss its cracking of big alkane molecules. How we can proceed this process? It can be done by thermal cracking. Therm mean heat. The word therm mean heat. We will provide heat to a big chain. There is a big chain. We will provide heat to crack it, to broken down into smaller pieces. We have to convert it into smaller pieces. So we will provide heat. The heat will be 500 degrees centigrade to the 700 degrees centigrade. Then again catalytic cracking. In the catalytic cracking we need catalyst Al2O3, SiO2, silica and aluminium oxide. Temperature will be between 300 to 500 degrees centigrade. A cracking in which we will use catalyst, we will say catalytic cracking. A cracking in which we just heat, the process is called as thermal cracking. So in the catalytic cracking, catalyst will be used. So what will be the product when we will heat a big molecule, oil molecule of alkane? What will be the products? So it will produce alkane plus alkene. One product can be one alkane and one alkene. Another product can be one alkane with hydrogen gas, or it can be one alkene and hydrogen gas. It can be one alkene and hydrogen gas. So here are the examples. Now let me give you one example. This is the first example. This is a big carbon atom with 18 and it can be cracked like this. The way how it can crack, it will be like this. It can be converted into a alkane with 8 carbon atoms, right? To make, if an alkane molecule is formed, a big alkane molecule in petroleum, for example, it's a very big molecule, an alkane molecule will be formed with an alkene. So how we came to know that this is alkane and this one is alkene? We will use the general formula CnH2n plus 2 for the alkanes, and for alkene CnH2n for the alkenes. So for alkanes and for alkenes we have the general formula to confirm either this is an alkane or alkene. So with 8 carbon atoms it is octane, and this one is alkene with 10 carbon atoms, decene. Okay, this is there can be another way, that there can be, if a long chain can be broken down into 6 molecules of ethene, this is another way to crack it. Or we can crack it like 6 with 6 alkane, that is hexane. So another way can be, we can make an alkene with hydrogen gas. This is an alkene and hydrogen gas will be produced. So how a question can come in your exam? First of all, the definition can come, the conditions, types of cracking, the conditions required for the cracking, and the question can be asked like this. Yeah, how a question can come? The big question. Yes. Write a balanced chemical equation in each case to show the cracking of C20H42 to produce, right? To produce an alkane with 6 carbon atom, right? And an alkene molecule. First of all, we will try to attempt this question, right? We have to write the answer here. We'll write it here. The answer, first question answer, yes. Alkane, for all of the reactions we will use the same alkane, that is C20H42. Okay. For the first reaction, what we are going to form? We are going to form an alkane with 6 carbon atom. You know the formula? How to use the formula CnH2n plus 2? Yes, you can use that formula and we will get the alkane like this. CnH2n plus 2, right? And alkene. So, how many carbon atoms are left behind? There can be an alkene. 20 minus 6, yes. 14, okay. Alkene with 14 carbon atoms. CnH2n, 14 into 2, 28. This is the formula for the alkene. Okay, next answer for the question B part. Yes. 8 ethene molecules, the C20 alkane will remain same, C20H42. 8 ethene molecules, right? We can make 8 ethene molecules. What is the formula of ethene? Yes, 2 carbon atom. Ethene with 2 carbon atoms. C2H4, right. How many carbon atoms are utilized here? 8 to the 16. Rest of the 8 ethene molecule and one other molecule. We can make one other molecule. We can make one ethane, one alkane or one hydrogen. It will be up to us. So we will make one ethene. If alkene is there, we will make smaller alkane. That will be of 4 butane. Okay. Now next is an alkene with 12 carbon atoms, another alkene molecule and hydrogen, right? We have the same C20H42. We have to write an alkene with 12 carbon atoms, right? C12. What is the general formula of alkene? CnH2n. Yes, check it in the previous video. Try to solve it by yourself. C12H24 plus 12 carbon atoms and one other alkene molecule. Yes, we will make one alkene molecule with the elimination of one other alkene. Okay, with the elimination of hydrogen gas. Okay, first of all, we will write hydrogen gas here and check how many carbon atoms and hydrogen atoms are left behind. Yes, 12 are gone. 12 carbon atoms are gone. Rest of the 8 carbon atoms. Yes, C8H16. Now count. Either we have write the balanced chemical equation. How many hydrogen atoms are there? 24 plus 2, 26. 26 plus 16, 42. So our hydrogen atoms are balanced. Our carbon 12 plus 8, total 20 carbon atoms are balanced. So this is the way through which cracking will be done and you will get the question in exam. So in the past papers, most of the time you will get the question, define what is cracking. You will define what is meant by the term cracking, define what is cracking. You can write how cracking can be take place. Any equation can give you like this. Any big molecule they will give you and you have to make the equations like this. So practice these questions in order to get good marks. So consistency is the key of success. Okay, now try to do the practice of this question. Pause the video, note the question from the past paper related to the cracking. The alkane C12H26 can be cracked to form alkene that has 6 carbon atoms per molecule. Construct the equation for this reaction. Again, I am repeating. Try to solve it by yourself. Alkane C12H26 can be cracked to form an alkene that has 6 carbon atoms per molecule. Okay, pause the video for a while and try to solve this question by yourself. Okay, an alkane C12H26 is cracked into an alkene with 6 carbon atom. Okay, C6H12. How can we generate this alkene with this? CnH2n. If we have this general formula for alkene, we will put the value for this C carbon atom. C6, N is the carbon number of carbon atoms. So C6H12 is for the for this reactions. So C6H12 is the alkene with 6 carbon atom, or rest of the 6 will be its alkane. Okay, C6H14. So this is the way through which you can we can write it like this, C6H14 alkane. Okay, there will be another way. This C12H26 can be broken down into 2 moles of C6H12 and rest of the hydrogen gas. So this can be the way through which all the hydrogen atoms can be C6H12, yes, exactly, 12 to the 24, 24 and 2, 26, and 2, 6 are 12 of carbon. So there can be 2 ways through which this molecule of C12H26 will be cracked. Okay, now I would like to discuss some of the questions for your practice and to get good understanding of the knowledge which I have given to you people right now. The question is from the CAI exam, O-level exam. The structures shown below are of the first 2 members of a homologous series known as the cyclopropane. The word ends in cyclopropane. So first of all, first information is this is the question related to the alkane, because ending name, the stem name of this is ane. So if we will discuss about this ane, we will say this is the ending name of alkanes. Yes. So this is the cycloalkane. Cyclopropane is cycloalkane. First of all, cycloalkane means it has all carbon-carbon saturated hydrocarbons. The first thing and first definition which comes in alkane, the specification of alkane is that alkanes are saturated hydrocarbons. The first hand knowledge which you have to write here, that is they are saturated hydrocarbons. So if we will talk about the saturated hydrocarbons, we will discuss it like this. So the very important question to get good understanding how we have to solve this question. So first of all, first questions. Members of a homologous series have a general formula. Okay? All the homologous series of respective homologous series have the same general formulas. So alkanes have the same general formula. State one other characteristic of a homologous series. What are the characteristics of homologous series we have discussed in this lesson? Yes, pause the video and try to solve it by yourself. Yes, there can be so many, like they have the same chemical reactions and same method of preparations. The answers which you can write here, same chemical reactions, same chemical reactions. They have they differ in the series. They differ by CH2 group. Differ by, if we are going to talk about the homologous series, the properties we have done, so you can check them again. Differ by CH2 or consecutive change in CH2 group. Differ by CH2. Same methods of preparation as we go down the group. Its physical properties are going gradual change in physical properties. So you can take any one of the gradual change in the physical properties. So you can check any one of the property change in the physical properties. So you can write any one of the property from the general properties, general characteristics of homologous series. Okay, deduce the general formula of the cyclopropane. So name ends at ane. Remember, name ends at ane. So when we are going to discuss when name ends at ane, how to write this ane formula for this ane? So general formula for the ane alkane is CN H2N plus 2. But if we have to write the general formula for this cycloalkane, So can we justify this? Is this a correct answer? Okay, let us check how to do this. First of all, we will check the molecular formula of this. How many number of carbon atoms are here? 3. How many hydrogen atoms are there? 1, 2, 3, 4, 5, 6. So in the cyclopropane, there is C3H6. If we will talk about this, 1, 2, 3, 4. Okay, C4. And how many hydrogen atoms are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And there are 8. But here we are saying that alkanes have the general formula CnH2n plus 2. If we are going to apply this CnH2n plus 2, then the formula should be C4H10. But here this formula CnH2n plus 2 is not justified. Put the values and check. No, it is not applicable. So check which formula can be. So this formula can be CnH2n. So use this formula and check, is this applicable here? CnH2n, please check here. If we will apply CnH2n here, so C3, carbon at N is carbon atom. So 2 multiplied by 3, C3H6. So here it is going to have this general formula, and CnH2n is the general formula for alkene. But in cyclopropane, the general formula which is going to be used is this. So whenever the word deduce will come in your questions, and then in that case you have to use your knowledge. You have to apply your knowledge in this question. So try to give your full take your full understanding and then try to apply it here. Pause the video, use these for both of these formulas. Which formula is applicable here? So in cyclopropane, we will deduce the general formula is CnH2n. Is it okay? I hope so. It is not going to be getting much more difficult for you people. So this is the question how you have to attempt it. So next question. Cyclopropane react in a similar way to alkanes such as methane. Wow. Write a chemical equation for the complete combustion of compound D. If we have to write the complete combustion, yes. Use your knowledge. What will be the products? Always when will be the reaction of complete combustion, whatever the compound is in organic chemistry, you have to write carbon dioxide and steam. Whenever we are going to talk about the hydrocarbons, they will produce carbon dioxide gas and steam. Products we know, but we must know what compound D is. So let's check. How many carbon atoms are there? C3 in compound D. How many hydrogens are there? C3H6. So good. If combustion is there, oxygen atom is there. So we have to write so this is the way through which we have to write the complete combustion. So how to balance the chemical equation? We will balance it. I will make another video once. Inshallah, very soon I will make a video where I will teach you how to balance the chemical reaction. So if we will balance, we can balance it like 2, 902, then it will become 18, 6 and 6. So here 2 3s are 6 carbon here, 6 carbon here. Okay, if we will justify the oxygen atoms, 18 are here, 12 plus 6, 18 are here. So hydrogen is also balanced. So this is the balanced chemical reaction. 1 mark will be for the writing equation and 1 mark will be for the balancing. So this is the division for this question in CAIE. Now next, suggest the type of reaction by which compound D reacts with chlorine. So all the reactions are similar to the alkane. What happens with the alkanes? We will write the same way of writing with this formula. If we will talk about the substitution reaction, so suggest the type of reaction. So type of reaction will be substitution reaction. Okay, if they are going to ask the question for this substitution reaction, if Another question he can ask, write down a chemical reaction for this substitution reaction. So what we will do for this chemical reaction, so there will be another way to write this chemical reaction. So very easy, that is we can write this C3H6 plus Cl2 in the presence of chlorine, in the presence of ultraviolet rays, sunlight, diffuse sunlight, not the direct sunlight, otherwise it will make an explosion. C3H6, only one H we will display it like this. How we will write? We will write it like this. C3H5, one atom will displace with Cl plus one HCl will come out. So check the substitution reaction previously, practice it again and write it twice or thrice and get the answer. Okay, next question is draw the structures of isomers. It will be our next topic, inshallah. Very soon I will teach you what are the isomers. So this is the end of this question. So I would like to discuss 2 or 3 more questions, how questions comes for the alkanes. So practice these questions, how very tricky questions are here, and how you have to attempt and apply your knowledge. So information handling question, one information is given to you people here, you have to handle your information and put all the information in this molecule and get the answers. So practice this and try to get good understanding. So next question. So we will practice one more question for the better understanding how to attempt the questions in exams. First question is, alkanes are a homologous series of hydrocarbons. You know, number of times in exam question comes that define what are hydrocarbons. So the compounds which contain carbon and hydrogen only. So there are 2 alkanes with molecular formula C4H10. Okay, draw the structure showing all the atoms and bonds of the 2 alkanes. This is the question of isomers. So inshallah in next lesson I will teach you what isomers are and then we will solve this question again. Next question, one of the alkanes with the molecular formula C4H10 is butane. Alright, we know that number of 4 with 4 carbon atoms, alkane is butane. Okay, butane is used as a fuel. Write the complete combustion of butane. So what we have to do, write down the complete combustion of butane, C4H10 plus oxygen. What will be the products? Yes, carbon dioxide gas and steam. In order to solve this question, first pause the video, try to solve it by yourself and then check the answer. So describe the problems associated with incomplete combustion. So incomplete combustion, what are the products which are produced? Yes, for the incomplete combustion, always remember, for the incomplete combustion, the products which will form are the carbon monoxide plus steam. And if the amount of oxygen is very limited, carbon soot particles can also produce. So this carbon monoxide gas is the fatal gas, where in the hemoglobin where oxygen attached, that this is called as oxyhemoglobin. If oxygen attached with this hemoglobin, in the place of oxygen, carbon monoxide gas will attach and will form carboxyhemoglobin. So the oxygen carrying capacity, carboxyhemoglobin, so oxygen carrying capacity for the carboxyhemoglobin will become very low. So fatal gas is, first of all, headache, asthma, then it will lead some lungs problems, then if more carbon monoxide is there, then it can cause death. So it's very fatal gas. So for the incomplete combustion, the problem which is a very much big problem, that is the production of harmful gases. So the next question is, yes, butane reacts with chlorine in the presence of ultraviolet reaction. Write an equation for this reaction. If butane C4H10 reacts with chlorine, yes, pause the video, try to answer the questions. Yes, ultraviolet rays, diffuse sunlight will come. Yes, what will happen? One hydrogen will displace from here. We will write C4H9Cl. One hydrogen will displace by an HCl product will be formed. So this is the way through which we will write the the reaction for the butane. Okay, construct the equation for the complete combustion of propane. How many questions are there in exams? Yes, repeatedly they are asking. What are the complete combustion of propane? We know C3H8 is going to produce, yes, which products? Well done, carbon dioxide gas and steam, that is H2O, it is going to be produced. So I hope so that you have learned very well about the properties of alkanes, how question comes and how you have to attempt and write the equations accordingly. Right? I hope so. In the next lesson, we will discuss the isomerism as well, because a number of questions are there. Isomerism. We will discuss the isomerism and the process cracking, which is also part of the alkane. So, next topic will be of our first alkenes, properties of alkenes. Then we will discuss the process of isomers. So, stay blessed. Consistency is the key of success. Signing off, Ms. Saisha Manzoor.